In this tutorial, we'll be going over scopes in Python and variable scopes within Python. So let's get started. To work with variable scopes in Python, we use a very simple rule. This is called the LEGB rule. LEGB is an abbreviation whereby each letter has its own meaning. L stands for local scope, E stands for enclosing scope, G stands for global scope, and then B stands for built-in. So what is when you mean global scope, we mean when you mean local scope rather, we mean local variables. So local variables are variables that are defined within a certain block and that cannot be accessed outside of that block. Global variables are variables that are defined outside of a block and can be accessed from anywhere within our Python code. So as the tutorial continues, we'll discuss about enclosing and built-in scopes. So for now, let's get started. So I have opened up my Visual Studio Code here. Why is it really important that you should study scopes in Python? So I have created a simple program here. This program simply prints global y or global y or local y. So if I run this code, just take a minute and pause the video and think what the output will be. So I'll run the code. We get local y and global y, but why that output? This is because of scoping in Python. So if you got this wrong, this is one reason why you should study scoping, and it's really a topic that most people don't understand. And if you are coding, it really leads to major issues within your code if you don't know on which scope do variables can be accessed or cannot be accessed. So let's get started. So we'll first be going over what is the global scope, and then we'll go to local scope, and then built-in, and then enclosing finally. So any variable that you define outside of a function or a block of code is known as a global variable. For example, y is a global variable. So if I try to print y in the global scope, which is we are printing it on the base indentation, that is a global scope. So if I run this, you see we get y, which most of you expect. So now I can even access this within a variable. So even when I print it, so within a block or a function. So even when I print y, let me call this function. So even if I run this code, I can be able to access this global variable y inside of a local scope, because we see that a local scope is a scope that exists within a block of code like a function. So everything that is away from the baseline and it's starting from the baseline of this block of code is known as a local scope. So we can access global variables even within that local scope. So when I run this code, we'll get global y twice. Okay, so that's what we get. So that is the local scope. So now, why are we getting this? How can you prove that these two variables are similar, or are referring to the same place in memory? So you can do this. I'm going to print the ID of y in the global scope, and I'm also going to print the ID of y in the local scope, so that you can see that in Python actually treats these two variables as the same thing. So I'll just comment out this. So let me run this code. It shows us that Python referring to these two variables within the same place in memory. So Python is referring these two variables point to the same place within memory. So Python is able to allocate them. That's why they have the same memory addresses. So this local variable is the same as this, the same local variable when we print it within a local scope. Okay. So I hope you understand what a local variable, a global variable is. So now let's move on to the local variables. So let me remove all of these statements. I'll just leave this for now, and then in here I'll say y equals to, and then in here I'll say local y. So in here I'll print y, right? So now let me first comment out. Okay, let me have it there. So you can see I have defined a function called func. It has a local variable y. So this whatever variable that you define inside of a block of code like a function is known as a local variable. And local variables have one major characteristics: they can't be accessed outside of that block of code or function. So for example, when I call this print statement, so when I call the function rather, it's going to print for us local y. Now what will happen if I run this way? If I try to print that y outside of that block, we get an error saying that name y isn't defined. This is because local variables can only be accessed within that local scope in which they were created. That's why we are able to write a print statement here, but not outside of that scope. So if I run this, I remove this, and I run the code again, everything should work fine. So this is what is known as a local variable. Local variables can't be accessed outside of the local scope, and the local scope is like within a block of function or class or something like that. Okay, so let's check. Let's say this. Let's name another function, another global variable y. So now let's try y. If we put in a print statement, we print y. What do you think? This was the problem that we discussed earlier. We got local y and global y. So why did we get that? Calling this function in the local scope, Python treats this, allocates a different memory address to this, and stores local variable y in there. So if you're printing that within that local scope, Python will refer to that memory address where this local variable is stored. But if you're outside of the local scope, we're in the global scope right now, and you're printing y, there is only one variable y within the global scope, which is the global y. So that's why if you print this, we get this, but if you call this function, it prints this, because Python treats these two different things at different parts of the memory. So how does this apply to our LEGB rule? So what Python does, if you call a print statement in here, first Python will look within the global scope. Does it have a variable y? So in this local scope we have a variable y, so Python will use that variable instead. It will not go on to the other hierarchies within our LEGB. Okay, so it will look within the local scope. If it finds that y, it will use it. It won't go looking for it in the other higher hierarchies. So if you run this, it will find y and it will use that y, and that's why we get local y. Okay, so now let's comment out this. Now if Python looks within the global scope, it doesn't have a variable y, so what will the output be? So just take a minute, look at this hierarchy, look at our code, and then think of how the output will be. Okay, just pause the video and think of how the output will be. So now I'll run the code. We get local, global y, and global y. Why did we get that? Look, coming here in our hierarchy LEGB room, Python will first look in the global scope. Does it have a variable y? It doesn't. It look in the enclosing scope. We have not yet discussed about the enclosing scope yet, but there is no y variable within the enclosing scope. We'll look at the enclosing scope just in a minute, but there is no variable y within the enclosing scope. So it moves on and looks in the global scope. This is the global scope. In the global scope there is y, and that y is the string global y. So it prints out that string global y. So that's what we get if you call this function, and also move there and prints global y, because this is in the global scope. In the global scope there is this y variable. So let's go over it once again. So print statement, Python looks for in the global scope to look for y, there isn't y. Looks in the enclosing scope, there isn't y, and then moves on to the global scope here where it finds this y, so it prints out that y. That's why we're getting global y and global y twice. Okay, I hope it makes sense. So now if we uncomment this and run it, we will get local y instead of global y, because Python will first look in the global scope, find y, so it will use that y. If we didn't find it, that's when you need to go into the other parts of the LEGB room. So now we have these two variables. Let's check something. I want to show you that these two variables are completely two different variables within Python memory. So I'm going to print out their memory addresses. So here we'll print out the ID of y. So we are printing the ID of y in the local scope and the ID of y in the variable in the global scope. We can see that these two variables are stored in two different parts of the memory, since the memory addresses are completely different. Okay, so these are completely two independent variables. So if I change this to y, the local y, and then I type in there, so it will not affect any other, it will only affect only this variable, since it has a unique place in memory which is completely independent from the global one. Okay, so local variables are completely independent from the global ones. Okay, so now let's say as I printed these two memory addresses, you can find that there are two different places in memory. What if you want to work with the same place in memory within a local variable? So to do this, we use the global keyword. So we simply say global, and then the name of the global variable that you want to use within your local scope. So if I run this code, I comment out this. So in here we have a variable named as global y, and we also in the local scope, and in the global scope we also have a variable named y. So let me just uncomment this. So now if I print the memory addresses, do you think they will be different like we got previously, or will they be the same? So let me just run this code and see. We see that the memory addresses are the same. So whatever we do to this variable should affect the outer scope, the global scope, since both the inner variable and the outer variable are pointing to the same place in memory. So this is what the global keyword does. It points the local variable and the global variable to the same point in memory. To illustrate this point, I've created a simple graph here. So we can see that global in the y in global scope and y in outer scope are pointing to the same place in memory, and this place in memory has a value of the variable. So whenever we change the value of the variable, this should be reflected in both the global scope and the local scope, since both of these are pointing to the same place within memory. So when I run this without printing the IDs, I want this one to print the content itself. So if I run this, we get local y and local y. Why did this happen? So Python, we call this function, Python moves inside of this block, wants to print y. So we want to print y. Python looks in the global scope, the local scope. Is there y? Yeah, y is there. But this y points to the same memory place as the global y. And this global variable y already has a value assigned to it, which is global y. Since they are all pointing in the same memory, and down here we are reassigning another value to that memory, so that memory, the value of that memory changes to become local y. So if you print that, we get local y. So the memory value has already been changed. So if you come out here and you're also trying to print y, since those the both local and global y variables are pointing to the same place in memory, and down here we have changed that value of that place in memory to be local y, this should affect the global variable. That's why if you print this statement, we're getting local y and global y, since during the first calling of this function the value has been changed already to this local y. So printing it out here, we are printing out local y. So if we change the positions of this and save this and run this, we should get global y and then local y, because we are printing out the global variable, right, which is global y, so it prints it out. And then after printing it out, it changed the place, so this has not affected this print statement. So if you copy this print statement and paste it here and save this and run this code again, what do you think we get? We get global y and then local y, local y, because this function changes that that value which is within that memory place which both local variables are referring to. Okay, so I hope it makes sense. So now let's move to built-ins. So built-ins in Python, let me just remove all of this. Built-ins in Python, you can just import it. So you can say import built-ins. So built-ins is attributes, different attributes that are predefined in Python. These are different like names that are predefined in Python. So we can just take a look at those predefined names in Python. So to do this, we can just use the draw function, and then in here we can say built-ins. So let me run this code and see what we get. So this will return to us a list containing all the built-in attributes or names that Python uses. For example, in here we can find there's a print, we can find print, tuple, open, object, range, supra, type, id, input, map. So all of these are built-in ones that you have been using. Even the print statement itself is in that here. You see it over here, is in the built-ins. So these built-in names, we shouldn't overwrite them. So for example, let me do this. So let me say print and then float. We want to convert the integer 3 to a float. So if you run this code, everything okay, let me remove this. So let me run this again. We get 3.0. So that the float function, that it changes an integer into a float point. That's why we're getting that. So now Python provides us the ability to override this built-ins float and then pass. So now if I run this code right now, we should get an error. So we get an error, float takes in 0 position argument, but 1 was given. So whenever you override these things, it will give you a problem. You have the ability to override them, but if you override them, it will give you a problem. So you should avoid overriding these names in Python, or these variable names in Python, variable names given to functions. Okay, so the built-in, if it comes to scoping, is not used quite a lot, so I want to go in depth into that. So just be aware that, keep them in mind, that you shouldn't override these built-in predefined names in Python. Okay, most of them are usually functions or an error name, so don't overuse them. Don't use them in your as variable names, and don't override them whenever working with your functions. Okay, so let's move on to enclosing. So let's do this. So I have a function here, I call it outer func, and this outer func has a variable y which is called outer y. Inside of this, you also have another function called inner func, and then this has a variable called inner y. So in here we're going to print y, and then in here also we're going to print y, and then also we are going to call the inner func. Call it, let's bring it above this, and then we save this code. So what we have here, we have what is known as enclosing. So this outer function encloses the inner function, so this is what is known as enclosing. Now if I run this code, what do you think will happen? Just take a moment and think about what this output would be by considering the hierarchy of the LEGB method that you have here. Okay, so we have the outer function which has a variable y, which and it has an inner function which has a variable y. So we are printing out this statement here. So what Python will do is that it look in the global scope. We are calling this function. This function is going to move into this. We are calling this function. Yeah, it will come in here. Look this print statement, so it needs to locate y, so it moves up. It looks in the global scope. Does it have y? So it gets y, so it will print inner y. And then if you come here, this is the this scope over here, it looks print statement. Does it have y within this scope? Yes, it does. It is the outer y. So if you print this statement, if you run this code, we're going to get, we didn't get any output because I didn't call the function. So call it here outer. So let me run this outer func. So let me run this and let's see what we get. We get inner y and outer y. The inner y is this function which printed this inner y, while the outer y used this other y. So this is how the scoping works. So now let me comment out this. What do you think will happen? Looking at this hierarchy, this is a scoping which I've already discussed here. So calling this function, it will move in this block, get a print y, so it needs to allocate y. It looks within its global scope over here. Does it have y within the global scope? No. It moved to the enclosing scope, which is this one over here. It moves to the enclosing scope, it finds y, so it will use that outer y. So if you run this, we get outer y, outer y. Okay, now let's come in, let's give y equals to global y. So let's run this code and see what will happen. We'll get the same output, outer y, outer y. So now let's comment out this. What do you think will happen? Pause the video and take a moment and think, considering this hierarchy. So what Python will do, this call this function, this will move in here, get this, find this print statement, it needs to allocate y. We look within the local scope, we don't have y. It will look within the enclosing scope, we don't have y. It will look within the global scope, which we have y. So if we print this, we'll get global y, which we get here. So this is how scoping works in Python. Okay, so I hope you understood this. So what if I uncomment this? What do you think will happen? Sorry, run this. We get inner y and global y. This is inner, it's in it. So inner y and global y. Why? When you call this function, it moves in here, find this print statement, it needs to allocate y. It finds y within the global, because first it starts within global scope, it finds y, so it prints out that y. Then this print statement, it looks within its global scope, it can't find y, so it gets from the outer scope, since there's no enclosing scope to this outer function, so it uses the global one. So this is how enclosing works in Python. I hope you understand. If you have any questions, you can leave in the comment section below, or you can follow me on Instagram. Please don't forget to like, to share, and to subscribe to my channel for more videos like this. Thanks for watching.